Hello, ladies and gentlemen. Sorry for getting this up a little late on the weekend. So we'll throw it up here. Now, the good news is that your quiz on Monday isn't going to have any of this stuff on it. So spend some time and look at it tonight and be ready for tomorrow. Okay, so common factoring. To find the greatest common factor of a series of terms, you must include the GCF, the greatest common factor, of the coefficients. Now the coefficients are the numbers. They're the number part in front of a term. So there's three terms here. This has a coefficient of 4, this has a coefficient of -12, this has a coefficient of 16. And you want the GCF of the variables, the greatest common factor of all the variables. This will always correspond to the common variable with the smallest variable. Okay, that's not. Let's get rid of with the smallest exponent. All right, so we're getting rid of this. Blah, yucky, goodbye. So the GCF of the variable, this will always correspond to the common variable with the smallest exponent. So let's look at here, the GCF. You look at the number part. The greatest common factor of 4, 12, and 16 is 4. Okay? I have an A to the 1, a B to the 1, and a C to the 1. I have an A to the 1, a C to the 1, and a D to the 1. This one doesn't have a B. This one doesn't have a D. So far, A and C are the only things in common here. This is C, Y, and A. So the A and the C are common in all of them. There it is there it is, there it is, there it is, there it is, there it is. The order of multiplication does not matter, as we've discussed, so it's going to be AC. Now the other way you could have written that is 4CA, or you could have written it as 4C or C4A, and all of that would be fine because it's all multiplication. This times this times this. This is what we're going to want to do though. Typically we keep alphabetical order. Sometimes that gets confusing because we also like to do it in decreasing order of the power variable, so how large the exponent is. The larger exponent comes first, but there you go. Now remember, I'm not factoring here. All I am doing is stating the largest or greatest common factor. So the greatest common factor between these three terms, notice they're separated by commas. So I'm thinking, I was thinking 12 here when I saw 36 and 12, but now I see 18. So 9 is good, but it doesn't go in these two. So 3 is good. 3 is great, it goes into all of them, but there's a larger one. And remember, I want the greatest common factor, so 6. 6 is going to go into 36 because it's 6 times 6. This is going to be 6 times 2. This is going to be 6 times 3. Now look at the variables. The variable is all x, so they all got some x. This has 2 x's, x times x, so it's x and x. This is 5 x's, x times x times x times x times x. This is 4 x's, x times x times x times x. So we can take 2 x's out of all of them. All of them have at least 2 x's in them. So that's the greatest common factor for those three. 16, 12, 18. It's not 4. It's not 9. I'm thinking 3. So 3 goes into 16. Thinking of my calculator, I don't think 3 goes into 16 at all. It does not. So I guess now we're looking at 2. 2 goes into 16 13 times, 2 goes into 12 6 times, 2 goes into 18 9 times. Notice this one. 2 goes into 16 8 times, 8. 2 goes into 16 6 times, 2 goes into 18 9 times. Okay, so that's the greatest common factor. Look at the A's. They all have A's. This has 4 A's, this has 2 A's, this has 7 A's all multiplied together. So I can take out a maximum of 2. X's, this has 4 X's, this has 3 X's, this has 1 X. When there's no exponent, there's an invisible 1. That exponent goes with the Y, it doesn't go with the X. If I want it to go with both of them, I would have had to written it like this. That would mean that the 7 goes with the X and the Y, but we didn't. We wrote it like this. Okay? That means the 7 only goes with the Y, and there's an invisible 1 up there. So, the most I can take out is a 1x out of all 3. Now look at the y's, y to the 3. Yay! Greatest common factor. Remember, I am not factoring here. I'm just finding the greatest common factor. Negative 12, negative 15, negative 3. I can common factor a negative 3 out of all of them. That's important, okay? We want to take out a negative if we can. So a to the 4, a squared a. Most I can take out is a from all of them. C squared, c cubed, c. Most I can take out is a c from all of them. And again, this is great the way I've written it. It also means this, which is probably a nicer way to write it, okay? I'm going to hit focus and see what happens here. See if this gets a little bit clearer. Ooh, focused. Not bad. Okay. Expanding. Expanding is the process of expressing a product as a sum or difference of terms. It's the distributive property, people. When they talk about expanding, they're saying the distributive property. So I've got a monomial out here. I've got a binomial in here. This is multiplication. Another way to write this is to put the 5 in brackets and leave the a plus b in brackets. And we know what we're going to do is we're going to take that 5 to everybody inside the room. Hey, everybody! And going to 5a and 5b, and that's called expanding. Factoring, you go the other way. This is the room. Everyone in the room has a 5 that's being multiplied to them. So we can take the 5 out of the room, and another way to write this would be, and that process is called factoring. So factoring and expanding are reverse operations. I don't like that word. That's not the math term. They're called inverse operations. They undo each other. Okay, so factoring goes to expanding, expanding goes to factoring, and around and around and around you go. They are inverse. I'm not happy with this word reverse. I won't accept it. The proper word is inverse operations. They undo each other. So for example, if I have 2 times a and then I divide by 2, I get back to a. They're inverse. All right, to factor an expression means to write it in product form. To common factor out the GCF, use the following guide. So there's 2 different ideas here. There's one idea. Here's the other idea. To factor an expression means to write it in product form, period. Now, there's different types of factoring. To common factor. Now, that's different, okay? That's not just factoring. That's common factor. To common factor, what we do is we take the GCF out. So you have your original expression, you have your GCF, and then you have your original expression divided by the GCF. This is one type of factoring called common factoring. It is one type of factoring, and always, there's other types, one type of factoring, and more importantly, we always do this first. Always check to common factor first. Always. Okay? And I'm a mathematician, guys. When I say always, that's a definite. That's always. You always check to common factor first. Okay, so look at this page. This page has all sorts of things written on it. You're sitting here watching the movie. You might be eating popcorn. You might be doing something. But I'm telling you, if you don't have these notes, and if you're not writing things out, and if you're not actively learning from this process, this video is worth nothing to you. But the fact that you have it, the fact that you can sit down and go over it and then come to me and ask questions later means everything to you. So your paper better look messed up a little bit. You better have this in your notes and it better make sense. Okay, so that's page 12, and I'm going to stop here so my videos don't get too long, and I'll do the next page.